Question 9, another stat question. So this one's actually way more straightforward. It's a tree diagram. They show a tree on there. So there we go. Keep in mind, do not write on this page. I'm gonna do it here for the sake of space, but on the IB test, you want to write on the separate paper they give you for these big ones. So let's see what's going on. Bill and Andrea play two games of tennis. The probability that Bill wins the first game is 4/5. If Bill wins the first game, the probability that he wins the second game is 5/6. If Bill loses the first game, the probability that he wins the second game is 2/3. So first thing I'm gonna do is complete this tree diagram. Couldn't be simpler. Now again, they want you to do some separate piece of paper. I'm gonna do it here for the sake of space. So if he wins the first game 4/5, that means, remember, all this has to add up to be 1. So 1/5 for Andrea. And then move on to here. This one they told me up here. They said if Bill loses the first game, that's down there, so Andrea wins. Probably that he wins the second game is 2/3. So the odds he wins the second game is 2/3. That means Andrea wins, odds of winning the second game is 1/3. And there you go. That's our first 3 points. B, find the probability that Bill wins the first game and Andrea wins the second game. So we want to find Bill and Andrea. So that's why I love tree diagrams. Right? So they want Bill winning the first game and then Andrea winning the second game. So all I had to do is multiply those two things. So Bill won the first game, and then Andrea. So Bill would be 4/5, Andrea would be 1/6. And I get 4 out of 30. That's B. C, find probability that Bill wins at least one game. So now it's a little tricky there, at least one. So we gotta find all possibilities. So Bill could win the first game and lose the first, and then lose the second game, like we already did. He could win both games. That counts as at least one. And he could lose the first game and win the second game. So those are all the possibilities you gotta find. So for C here, we gotta do all those. We gotta do BA, which we already did, 4/30, classic IB. We gotta add BB, and we gotta add AB. So Bill wins both of them would be 4/5 times 5/6. Andrea winning the first game is right here is 1/5, and then Bill winning the second game is 2/3. I got messed up my fractions. So 4/30 plus 20/30 plus 2/15. We're gonna add all these together. So I need a common denominator. So let's multiply this by 2/2. So I get 4/30 plus 20/30 plus 4/30. And I get 28/30. So that's odds that Bill wins at least 2 games. Okay, last question on this problem. Given that's very important, right? Given that is the line. So given that he wins at least one game. So given that he wins at least one. I'll put at least one. Find the probability that he wins both games. So Bill. So that's what we gotta find. We gotta find the probability he wins both games, given that he won at least one. And until we do that, I like to use the formula. So it's in your formula sheet. It's this. A given that problem is this. B given A equal times probability of A. Well, let me do this. Equals probability of B given A times the probability of A equals probability of A intersection B. So that's the formula. So all we gotta do is fill that out. Now, right, in our case, we're using probability that he wins both, given that he wins at least one, times the probability that he won at least one. Gotta find an easier way to write this. Equals the probability that he found both games and at least one. So when we fill this out, this is what we're looking for. So let's make that X to make it easy. Probability he won at least one, we actually found that out already, right? That's up here. That's all we did in C was find probability he wins at least one game. Classic IB. This is 28/30. This is typically the toughest one. So you gotta use a little logic. You gotta go, okay, what's the odds that he wins both games and he wins at least once, right? That's what they have in common. So what do these two things have in common? What we did up here. The probability he wins at least one and wins both games is just this guy. Just BB. Right, this is essentially saying, what does BB and BA, BB, and AB have in common? Only thing they have in common is probability wins both games. So this odds right here is the probability wins both games. And we actually found that already also. Probability wins both games is 20 over 30. So this should be 20 over 30. And that looks disgusting. Let me write it a little nicer. 28 over 30 x equals 20 over 30. All I gotta do now is solve for x. So multiply by both sides by the reciprocal of 28 over 30. So 30 over 28. Stuff cancels, and you get x equals 20 over 28. So that's a probability that's a given net probability. And that's the end of the problem.